Hey, Stats. I didn't have a lesson on Wednesday because we did the review on page 107, 108 for the quiz that we'll have on Tuesday next week. So on page 107, it talks about presidents' ages. So we want to create a histogram in using their ages to as our thing. So we got to go to our friend the Desmos. Remember, we have to label it. I don't know. We'll call it L. Open bracket. Now I'm going to put the president's ages in. So looks like 42, 43, 46, 46. Oops. 47 and 47. 48. 49. 49. 50. 51. 51. Let's see, we have 1, 2, 3, 4, 5. 551, so I threw it to them. 1, 2, 3, 4, 5 54s. 1, 2, 3, 4, 55. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3 56s. I have 1, 2, 3, 4 57s. 58, 60, 361s, 62, 264s, 65, 68, 69, and 70. It looks like we don't have Joe Biden, just our list is incomplete. So then we're going to create a histogram equals our histogram, open parentheses, L, and maybe we'll make it 5. Nope. Oh, add 2 open parentheses. There we go. So I'll make it 5. So there's our histogram. So let's create a histogram, provide all necessary labels. So if looking at this, if we had a bandwidth of 5, this would be 32, 34, 36, 39. So width of 5 to 43, 43 to 47, 47 to 52, it looks like, so on and so forth. So our title on the bottom would be age range of presidents. Our y-axis would be how often they are that age, how many of them fall into that region, and then the title of it could be presidents' ages at the start of their presidency. Okay, then we want to find the mean. So if we do type in mean, put in parentheses of L. So the average age of the presidents was 55.02 roughly. If I wanted to find the median of L, looks like the median age was 55. So the mean and median are very close. It would probably mean we don't have any outliers. So interpret the meaning and context. The average age of presidents was 55.02 years when they took office. The median is 55. That means half the presidents were above that age and half the presidents were below that age. The median is the 50th percentile. Create a stem plot of US presidents. So I think we can do stem plot. Nope, I have to find this. So I'm going to go to here, functions, and I need to find the stem plot. Or it's called a box plot sometimes. All right, wait, we don't have a stem plot. So what I'll have to do is with the presidents, their ages started at 40, 50, 60, 70. That's the stem. And then 2, 3, 6, 6, 7, 7, 8, 9, 9, 50, 1, 2, 2, 4, 4, 4, 4, 4, 5, etc. And so I'm not going to write it all out, but you should be able to do that. And then what would be the advantage over a stem plot over a histogram? A stem plot shows the 40s, the 50s, the 60s, and the 70s. What I could do is if I modify this and perhaps I create this to be a width of 10, right there, that's basically what our stem plot would look like, but we would turn it sideways. Obviously, this only has 4 columns because we only have ages in the 40s, 50s, 60s, and 70s to go there. And so there we go. If we align it left, so the 40s, 50s, 60s, and 70s. So you had 1 here, 10 here. Looks like 22 would fall into this region, 9 would fall into this region. Create a stem plot of USA. You may want to split the stem for this data set. So what I could do is if I made a stem plot based on 5 and I turn this sideways from 40 to 45, from 45 to 50, 50 to 55, so on and so forth, but turn it sideways. This obviously doesn't show their exact ages, so we'd lose but that would just give us a way to look at it. What is the advantage of a stem plot over a histogram? It really is just that you're able to get the exact ages, see how many exact ages there are, so you maintain your data. What is an advantage of histogram over a stem plot? The histogram gives you a visual of the columns based on how wide our stems are. Okay, so then what I'm going to do is I'm going to go back to, we're going to do 1-8. So I'm turning the book back. Okay, so 1-8 talks about, this is on page 17. So you're talking about the center and spread of your data. You're looking at a shape. So the shape that they have kind of this looking shape, and I'm not going to draw it perfect. You can obviously look at the diagram. And clearly I'm not drawing it real well, but so if you were to talk about the shape, if you try to draw yourself a smooth curve over this, so you basically are getting a shape that looks like this. So being that we have a bigger tail over here, this is something that is called skew left. It means our tail is being pulled over. What a skew left basically means is that our median is to the right of our mean. Our mean is to the left. Our mean is pulling making the tail pull out a little bit further. Okay, so if you're looking at the distinct shapes on the middle of page 17, it says the bars of histogram form a distinct shape. If you were to smooth it out, the histogram curve might look something like on the bottom part of page 17, kind of what I have drawn. on the left side. They have generic shapes. In statistics, we provided terminology for these shapes, but there's all kinds of shapes. Most common shapes are shown in the diagrams below. So if you turn over to page 18, you have a normal distribution. So a normal distribution means that your curve looks normal. A negative skew means that the tail pulls more to the left. A positive skew looks like this. So this could be called a negative skew, or you could call it left. This could be a positive skew, which is skew right. Okay, there's bimodal, where that would just basically mean you have something like that. You have a J shape, you have an inverted U, and then there's rectangular, which really doesn't show up all that often. The first thing you should see is there is symmetry about this one. There's also symmetry about this one and this one, but the main one that we're going to look at is the symmetry of this one. That's called a normal curve. So symmetric distributions, you have the normal distribution, which is referred to the bell curve, which I have circled in the pink. Most of the results huddle in the middle, close to the mean. So the mean, you want it right in the middle. So that this dotted line here, this is the mean. It's becoming, as you get your events, as you go out this way or this way, the events are more rare in the tails of it. So you might do something like, you could say an average height of people is becoming more and more rare, the shorter a person is or the taller a person is. A rectangular distribution is called uniform. So this one down here is called uniform distribution. This means that the observations to the right or left are just as likely as happening as they are. So where you might see something like this, if you rolled a single die and the numbers on a single die, I'm not talking about a pair of dice, I'm talking about just one of them. If I rolled these a whole bunch of times, the probability of throwing a 1, a 2, a 3, a 4, a 5, or a 6 are all the same, so that would create a rectangular. If you had a pair of dice, that's different, but a single die would give you something like that. Bimodal means we would have two modes or two peaks. Okay, a mode is the most occurring number. So if I had, say, like numbers like this, twos are the most occurring and fours, so this is called bimodal. Okay. All right, so then on page 19, it talks about skew left and skew right. So skew left is negative skew. Skew right is positive. And we will refer more of skew left or skew right very often. Skew left, again, you have your tail more to the left. Skew right, your tail is to the right. So things are pulling it. That, in this case, the mean would be pulling it. Okay, skew left distributions of a peak at the right side showing a large number of values relatively high. So just read what's at the top of that about skew left and skew right. Symmetric distributions have a mean that is roughly equal to the median. So if you have a normal distribution, if the red line's the mean and the blue line's the median, they're relatively the same thing. Skew left distributions have a mean that is lower than the median. So the mean is less than the median on skew left. Skew right, my mean is greater than the median, or to the right of it. And then often the quoted rule in statistics is this: the mean is pulled towards the skew. So the mean is what is being influenced by the things that are at the tails. It's getting pulled to the right or to the left. Okay, so with that, I think you should be able to handle the homework, which is on 1-8, which would be page 111, 112. Page 111, 112. Hope you have a nice day.